Okay, what's the drill when you're adding and subtracting fractions? What's the deal? In order to add and subtract fractions, your denominators, or the bottom, has to be the same. So you're looking for same bottoms. All right? These ones all have them. Now, despite years of practice with this, with a calculator, some people still can't add and subtract fractions. Some people think that when you are adding and subtracting, you add and subtract the denominators as well. You do not. The denominators never change once they're the same. But you can't add and subtract without having them be the same. All right? Allie, what'd you get on the first one when you add these two? When you reduce, you get 4 over 5. Anybody who's doing these across the page and putting equals, 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 I'm going to put -1, and I'm going to put an arrow down. I am done with not following directions of how you solve expressions, simplify expressions, and solve equations. Down the page. All right? No equals here. How about number 2, Dane? What'd you get when you added those?
16 over 2x, and then 8 over x.
And then 8 over x when you reduce the 16 and the 2. Taylor, how about the last one? Yes, and then the new math, that would be? Thank you. Over? No need for you to do those problems. So -2 over x minus 3. With subtraction, you need to be extremely careful. When the second numerator is a binomial or a trinomial, you have to distribute the negative.
Could you multiply the -2, well, could you multiply it all by -1 so that the -2 and -3 equals, or just +2, +3?
Well, first of all, if you did multiply the bottom by -1, you'd get -x plus 3.
And then could you put that on top, or would that?
No, these are not powers. They're just negative numbers.
Okay.
The only way we move up and down is with negative exponents. If there's a negative on the top, that's really not a problem. If there's a negative on the bottom, we will usually transfer it to the top. But we're only doing that by multiplying by -1 over -1.
Okay.
In this case, it doesn't help us at all. A pretty good observation, though. And we will need to deal with that later on. Any questions on these 3? Okay, so this is the book work. If you want to see it again, if you're going across the page with an equals, that's not acceptable. So I'm not real big on these book notes. This is section 5. It's adding and subtracting rational expressions. We're going to start off with applesauce. Pre-digested. Already easy to just put in and swallow. You're good. No chewing necessary. Easy. Denominators are the same. What do you do with the tops? Just add or subtract. 12 minus 2. So when we're simplifying here, we're going to get 10 over, the denominator doesn't change. So when they give it to you and it's already got common denominators, that's all good. Really simple. 10 over 5x, how does that simplify?
5 over x.
How much? 2 over x.
2 over x.
2 over x. 5 over x. Who said that? Well, think about it. That's the kind of mistake you guys are going to make in this section. It's not a I don't understand how to reduce. It's a total brain freeze. So you've got to make sure you're paying attention to what you're doing here. So 2 over x is where we're headed. Okay? So 2 over 3x plus 1 plus x over 3x plus 1. 2 over 3x plus 1, x over 3x plus 1. Lindy, what do you get?
2x over 3x plus 1.
give you the 3x plus 1. Not helping. What does it say to do to the top? 2 plus x. So 2 plus x over 3x plus 1. That's a great answer. No points off. Sarah, you're not going to put that down, though, are you? What are you going to put?
2 over.
Not overthinking it. What are you going to write? How come? Because that's what kind of order? Begins with D, ends in descending. Descending order. Now, I don't care on this problem whether you switch 2 plus x to x plus 2. It really doesn't matter in the whole scheme of things. But what I'm trying to do is get you really well prepared for what's coming. And what's coming is that you're going to have to be solving. No, because of the plus signs. Okay? So think about this. 3 plus 5 over 3 plus 9. Can we cancel these and get 5 over 9? Or would you get 6 over 10? I'm not sure. If you do that, would it be equal to 8 over 12, which is 3 over 4? And the answer is no. These plus signs prevent you from canceling. So we don't want to do that. Little things in life. Okay? Everybody good here? We're not going to lose you, are you? Are we, Matt? Okay. It's looking kind of sketchy. Let's talk about what we're going to do when we don't have common denominators. Okay? And you're looking for a least common denominator, which is going to be the least common multiple of each denominator, or each term here. Now, least common multiples. Here's the drill. You want to factor, factor, factor. And if you have numeric factors, number factors, you want to prime factor those and write them exponentially. So if you look at our first term, 5x squared minus 45, how can I factor that? Yeah, take out a 5 and you'd be left with and x squared minus 9 factors how? Right? So you need to factor each of these completely. 4x squared plus 24x plus 36. So if we factor out a 4, we're left with x squared plus 6x plus 9, which factors to
X plus 3 squared.
not or in this case. We don't want to do or. We want to write it as a binomial square. Because the next thing you do is you look at your terms. You look at your terms here, and you say, I need every factor that you see in these two factorizations. And I want any common factors, anything that appears in both, to be raised to the highest power. So here's the first question. Look at what I have here, and I'm going to take this 4, and I'm going to rewrite it as 2 squared. It doesn't matter in this problem, but just to help you for the future, you're better off writing it as 2 squared if you have trouble finding the LCD or the LCM for constants. Look through here. How many different factors in the two factorizations do you see? How many different factors are there for these two terms? Right here. 2, 3, 5, 4, 7. Do I hear 8? 10. Good. So eventually you'll hit the right answer, which somebody did. how many different factors are there in the first factorization?
3.
3. A 5, an x plus 3, and an x minus 3. 3 factors. How many factors are there in this factorization?
2.
2. There's 2's and there's x plus 3's. Now my question is, how many different factors are there in the 2 factorizations? 4. There's 5's, there's x plus 3's, here and here, x minus 3's, and 2's. So the LCD, or the LCM in this case, has to have every factor to the highest power available. So the LCM has to have 5's, 2's, x plus 3's, and x minus 3's. Those are the factors that have to appear in the LCM. Now, do any of them get powers? Well, we want the highest power available for each factor. For the 5, it's a 1. For the 2, it's 2 squared. X plus 3 is highest power that you see written on the board for the factor. Squared. And x minus 3 is just for the first. There is no x plus 3 cubed. You don't have that as an option. Your option is squared or first power. Which one do you want? You want the bigger one. Then simplify. This becomes 20 x plus 3 squared and x minus 3. Why do people struggle so much with this chapter? Because they can't factor and they don't have a clue on how to do fractions. And they just make it up, and it's not going to work. You've got to follow the process. And if you try to skip steps, it's going to be bad. Try this one. See if you can find the LCM for these. Okay, so when we factor, the 4x squared is good. What's the common factor for the second one? 4x. And you're left with 2x minus 3. How many different factors are there? 3. There are 4's, there are x's, and there are 2x minus 3's. What's the highest power that I can choose for the 4? 1. How about the x? 2. How about the 2x minus 3? 1. So this is your LCM. If you're not seeing it, it's not that it went anywhere, okay? What we're trying to find is an expression that 4x squared will divide evenly into, and 8x squared minus 12x will also divide evenly into. Now 4x squared, you can see, will divide evenly into that. In this one, when you factor it, you can see that there's a 4x that would factor out, and then the 2x minus 3 will go in also. So again, we're not trying to put them together, we're trying to find the term, the expression that they'll both divide evenly into. Okay? Not unlike taking a 4 and a 6 and saying the least common multiple is 12. They both divide evenly into the 12. But 4 is 2 squared. 6 is 2 times 3. When we take the 2's, you don't take all 3 2's, you take 2 squared. Times 3 gives you 12. Okay? Does that make sense? You need to see it? That's what we're doing here. So now we're looking at adding fractions that don't have common denominators. You make them common. Okay? Now in this one I'm going to go through the process, even though I know all of you, or at least I'm pretty sure all of you could do this without the process. The numerators don't matter. 7 over 2, 9 over 20 is 2 squared times 5. 20 is 2 squared times 5. The LCD for these two denominators has to have 2's and 5's. The 2 has to be raised to the power of 2. The highest power available on the 2 is squared. The 5, we only have one choice, and that's to the first. What do you need to multiply 2 by to get 2 squared times 5? How do you get the 10? I want to look at this right here. I know that we can go 2 times 10 and get 20. What I want you to see is, what do you multiply 2 by to get 2 squared times 5? Again, 10 would be a bad answer. A correct one, but a bad one. Correct. You would multiply by 2 to get 2 squared and times 5. So on the top, you're going to multiply by 2 times 5. And again, I'm not suggesting that you need to do all of this on a number problem, but you should also be able to intuit at this point, not a test question. This is just a review from 5th, 6th grade. Can you do this? This is how you do it.
Why did you put this, like when it says like the plus and you have a blank, why did you put 2 squared?
I'm not on that one. I was just doing the first fraction. I'm going to go there in 1 second. So the LCD here, 2 squared. 2 squared times 5 is what we had here. What do I do to get to this one? So, yeah, you do nothing in essence. So we leave it 9. 7 times 2 times 5 is 70, plus 9 is 79 over 2 squared times 5 is 20. Of course you aren't going to go through that whole process. But if you don't understand the process with the numbers, when we go to the variables, it's just going to be deer in the headlights. So we want to avoid that. Does anyone have a problem with what we see here? So now we do it with variables. What's the LCD going to be? 4. No, 4x. You have to have every factor you see to the highest power available. We have 4's and x's. Here's another x. We just have 4's and x's. What do we do to 4x to get 4x? Nothing. So don't do anything to the top. What do you multiply x by to get 4x? 4. Multiply the top by 4. So what you're, in fact, you're multiplying by 4 over 4. What's that equal? 1. All we're doing is multiplying by 1 in this special form of 4 over 4. It's the only thing you can multiply by and not change the value of the fraction, or any other number for that matter. When we add on the top, 43 over 4x. I cannot tell you how many times I get 43 over 8x, or 43 over 16x squared, or 43 over 4x squared. Okay? You don't do anything to the bottoms. Leave them alone. Okay? What's the LCD going to be? 5 x minus 3. Down the page, no equals, vertical, vertical, vertical. What do we do to x minus 3 to get the LCD? So we're going to get 35 on the top, 5 times 7. And on the other side, leave it alone. When you subtract, you're going to get 26 and 5 quantity x minus 3. If it was 25, you could reduce. If it was 30, you could reduce. 26, not so much. That's the way it is. Does anybody have a question on this so far? Pretty easy. It's not the easiest. It's not common denominators to begin with, but it's pretty easy. See if you can do these, add these up. So I expect to see at least this line, 2, maybe 3 more lines. So if you want to see it as 2 times 5 times x to the second, that's perfectly fine on that fraction. How does the denominator factor over here? How does 5x squared minus 10x factor? 5x times x minus 2. Okay, good. The LCD. The LCD. What has to be in the LCD? So specifically, 2, 5, x, and x minus 2. What power do we want on the 2 and the 5? 1. And the x squared, and the x minus 2, 1. So 2 times 5, x squared, x minus 2. Again, if you can do this without doing 2 times 5 and you wrote a 10 here and a 5 here, I'm okay with that. So here's your 10. Here's your 10 in the LCD. I'm okay with that. What do we do to the left denominator to get down to the LCD? What do we multiply by? X minus 2. So we multiply the top by x minus 2. In parentheses. What do you do on the right-hand side to get to the LCD? 2 and x. We need another 2. Added, multiplied times the 5 to get the 10. And we need an x times x to get x squared. So we're going to have 2x times another 2x. That's going to give you 3x minus 6 plus 4x squared over 10x squared times x minus 2. What's wrong with that? What's that? Yeah, I've got to rewrite the top. Why do I need to rewrite the top other than descending order? There's a bigger reason. Because you might be able to factor. How does this factor? No, because it doesn't go into the 4x squared. So 3 is only common to the last 2 factors. The last 2 terms, excuse me. How's it factor? Some of you are sitting there thinking, thank God we're not checking this because I don't know how to factor. I'll just wait and someone else will do it. How does this factor? This is a 10-second problem. Maybe less than 10 seconds. How do you know it doesn't factor? Well, if you borrow from the clouds, 4 times negative 6 is negative 24. Factors of 24 that subtract to 3. You got 4 times 6, they differ by 2. And 3 times 8 differ by 5. This is not factorable. So we don't worry about it. But if you can't tell it's not factorable, believe me, it's going to be bad news bears for you. Try this one. Well, since we do have only a few minutes, let's speed this up just a tad. What's in common here?
Correct.
2x and x plus 2, right?
Yeah.
So if you look at this one, and notice I didn't rewrite the 4 as 2 squared, which you can if you want to go exponential. But if you look at the 4 and the 2, what's the smallest number 4 and 2 both go into? 4. How about the x's? What am I going to take? X squared, because that's the bigger power. And then we got to have x plus 2. So 4x squared, x plus 2. What do I have to multiply the left side by? X plus 2, top and bottom. What do we multiply the right side by? 2x. X plus 1. Am I going too quick? Everybody following? So on the top, you're going to get 5x plus 10 plus 2x squared plus 2 over the LCD, 4x squared, x plus 2. Did I make a mistake?
Wouldn't it be if it's 2x to x or 2x plus 2?
Did I say 2x plus 2? 2x squared plus 2? Okay. So now you're going to go descending order, 2x squared plus 7x plus 10 over your LCD of 4x squared and x plus 2. Does the numerator factor? No. There are no factors of 20 that add up to 7. So this is a good answer. So this is what I want you to look at tonight. Right? This should be, for the most part, straightforward. Get a common denominator, combine,